Hey guys, welcome. So I assume that you watched the intro video to the product rule, and so I'm not going to give as many details here about like every little item that I write, but yeah, um, let's get started. So we'll similarly motivate the quotient rule as we did with the product rule by thinking about something like this, which is so we know that log base 2 of 4 is equal to 2, right? But if we so chose, we can argue that log base 2 of 4 is the same as log base 2 of 64 divided by 16, right? There are 4 16s in 64. So this quotient is 4 in value. So this is the same as that. Okay. So then how should we move forward? If we want to write like log base 2 of 64 and then log base 2 of 16 is like separate logs. Well, let's first write that. So let's write log base 2 of 64 and then log base 2 of 16. And first note that we know it needs to equal, since this is the same as that, we know that this here needs to equal 2 on the left side, right? That's my 2, that was poor, so that's better. And now we know that this here is 6, right? And we know that this here is 4, so it's obvious what we should do. We should write a minus sign because 6 minus 4 is 2. So there that is. That's the quotient rule. So some of the details I'm not going to explain in this video that I did in the product rule video are like why we write absolute value around the argument of logs. Technically I should write an absolute value here, but I knew I didn't need to. Anyway, the quotient rule written formally would say that log any base a of the absolute value of x divided by, I answer why these absolute values are required in the video on the product rule. So yeah, I won't say that detail again, but yeah, log base a, where a is any base, log base, right, is of x divided by y, absolute value of x divided by y, is equal to log base a of absolute value of x minus log base a of absolute value of y. In a different video, I prove this quotient rule, so check out that proof. I'll at some point link the video of the proof of the quotient rule below this video. Okay, cool. This is the quotient rule, and I guess I'll give you one more example, and I'll have us simplify some logarithmic expression, I suppose. So what's a good example? Let's see. So suppose that you have to deal with this, which is log base, let's say 3, log base 3 of, let's say you have x squared minus 1. So again, technically I need absolute values, but I'm going to proceed without them. It's being lazy and casual, but the same process would follow if we wrote absolute values. But yeah, let's say that you have this, and then you have minus log base 3 of let's say x minus 1, and then minus log base 3 of x plus 1. Sorry, I'm making this up as we go along. So yeah, bear with me. Okay. So what now? Well, you can do this. One is to apply the quotient rule here, and once you've done that, to in turn take the result here and apply the quotient rule by pairing it with that. So let's do that. That's actually my less preferred approach. There's a different approach that I think is better, which I'll show you shortly. But let's take this approach, and yeah, I didn't know if that was just on my computer or anyway. Yeah, okay, so if we take this approach, we want to use the quotient rule here to go from this form to that form, right? Okay, so that would mean we write log base 3 of x squared minus 1 divided by x minus 1, right? So this here is the same as those two together, right? Okay, cool. But I still have to write that. So I'll write minus log base 3 of x plus 1. I think like because it's simplifies in here, it'd be best if you simplify here first before you move forward. But yeah, so this is what I'm saying. So right, log base 3 of, well, this here is like in the numerator x plus 1 times x minus 1, factoring using difference of squares, one of my favorite things in the world, as I've said in many videos, divided by x minus 1, right? And this obviously is just that, right? And in case you missed it, this here is that, right? Okay. And then you'd have minus this still, right? But I won't write that yet, like, because we see that we can cancel this and this here. So we can write this a bit more simplified as just log base 3 of x plus 1. So I'm going to go back and write that instead. And so log base 3 of x plus 1, you probably see the end. And so this is just a simplified version of that. And we still have the minus sign, right? And then this still. So minus log base 3 of x plus 1. But then this is equal to log base 3 of, well, it's x plus 1 divided by x plus 1, where I went here by applying the quotient rule again, right? Okay, right there is that, right? Okay, that version of this, right? Okay. Anyway, so this is log base 3 of 1, and we know log any base of 1 is 0. So this is equal to 0, yeah? Okay, cool. But this is not my preferred approach to solving this problem, as I already said. And so, like, at this stage, we've simplified it as much as we can simplify in this direction. But yeah, like, let me show you my preferred approach, which should be to do log base 3 of x squared minus 1, and then to write minus and factor out this minus sign from there, and write log base 3 of x minus 1, and then plus log base 3 of x plus 1. Now here what happens is, in here you have to use the product rule, because the product rule says log base a of absolute value of x times y is equal to log base a of absolute value of x plus log base a of absolute value of y. And I've linked a video, or I'll link a video of the proof of this below this video. Yeah, I discuss it in its own dedicated video, like just like this one, where it's product rule intro, which I said you should watch. Anyway, so then, going from here to here, and there, we see that we can write log base 3 of x squared minus 1 minus log base 3 of x minus 1 times x plus 1. But wait, this here, if we multiply, it just turns into x squared minus 1, right? So we could just write log base 3 of x squared minus 1. Now this extra parenthesis here and here is not necessary, but I need it at the start, so it's fine. But now all we have left is an application of the quotient rule. So in this second solution, which I prefer to simplifying this, I think, you use the product rule and the quotient rule, but it's more efficient. So yeah, log base 3 of, in your next step, x squared minus 1 divided by x squared minus 1. Of course, we expect that the result will be the same as before, which is log base 3 of 1, which is 0. Yeah? Okay, cool. All right, this is it for the quotient rule introduction. As I said, I do a proof of this quotient rule, so watch that video, and then watch the product rule video intro, and then the product rule proof, and many more log videos to come. Yeah? Okay, cool.